Let us learn how to find own price elasticity of demand from the given utility function. Question is find own price elasticity of demand for the given utility function u is equal to x1 into x2. X1 and x2 are the two values. So we have utility u is equal to x1 times x2. This is our utility function. We want to find out the price elasticity of demand for good x1 and x2 here. Okay, so that means first we need to find out the demand function for good x1 and x2. To find out the demand function, we need to construct the budget constraint. Let us say P1 is the price of good x1 times units of good x1 plus price of good x2 times units of good x2, and it should be exhausted all. That means income should be exhausted on the goods x1 and x2 given the prices as P1 and P2. Our question then becomes, that is, we want to maximize this utility function subject to this budget constraint to find out the demand function. Okay, now for optimization we know that first order condition for optimization requires that marginal rate of substitution between good 1 and 2 should be equal to the ratio of the prices, that's P1 upon P2. MRS of good x1 and x2 is simply the marginal utility of good 1 upon marginal utility of good 2, and it should be equal to the ratio of the prices P1 upon P2. Now what is MU1? MU1 is simply the partial derivative of utility function with respect to good x1. So taking derivative of this function with respect to x1, we are left with x2 because derivative of x1 is 1. Symmetrically, marginal utility of good x2 will be the partial derivative of utility function with respect to good x2. This time we take derivative with respect to x2, its derivative is 1, so we are left with x1 here, which implies mu1 upon mu2 will be x2 upon x1. X2 upon x1 is equal to p1 upon p2. Let us solve it for x2. So transposing it will get multiplied here. So x2 is equal to p1 upon p2 x1. After that we plug the value of x2 into the budget constraint here to find out the demand function. So we have p1 x1 plus p2. In place of x2 we have p1 upon p2 x1. Okay, so p2 gets cancelled, so we have p1 x1, it will sum up to twice p1 x1 because these are the like terms which should be equal to m. That gives us demand function for good x1 will be equal to m upon twice p1. By symmetry you can find out the demand function for good x2 will be also equal to this, but the prices will be then p2. So I will not write that, or let me write it here. Similarly, you can find out demand function for good x2 will be equal to m upon twice p2. Okay, now we are done with the demand functions. Let's try to find out the elasticity of demand. So what is elasticity of demand? Formula is simple. Price elasticity of demand is derivative of demand function with respect to price into p1 upon x1. Okay, so first we need to find out dx1 upon dp1. Dx1, we differentiate this function with respect to price. Okay, so dx1 upon dp1 means the derivative of this function with respect to price. Now derivative of 1 upon p1 will be equal to minus m upon twice p1 square. Okay, this is the derivative of, if we have 1 upon x, its derivative is minus 1 upon x square. Okay, so elasticity will be equal to dx1 upon dp1. We got it as minus m upon twice p1 square into p1 divided by x1. X1 is this m upon twice p1. Okay, here we can cancel this m and this m, 1p and 1p, this 2 and this 2, so we will get minus 1 upon P1 into this P1. So P1 gets cancelled. We get elasticity of demand is equal to -1. Okay, so this is the price elasticity of demand for good x1, and similarly the price elasticity of demand for good x2 will be equal to -1. In absolute terms, you can write, you know, elasticity of demand is equal to 1. Okay, I hope I make myself clear in this video. Thank you.